putting into, taking out of, and then math. So addition, subtraction, multiplication, and division with scientific notation. You are also going to have conversions. So you're going to have just metric to metric, where you will move decimal, and then factor label where you'll set it up as a problem. Then you'll have metric, English, cubic, rate, and temperature. And then you've got density problems. And then significant figures. IDing the number of sig figs. And then writing answers with the correct sig figs. And then accuracy and precision. Okay, so that's your test. Hold on, let me let these last few people in. So this is what the test will cover. So and I'm gonna take this, I'm recording this, and I'll put the recording on YouTube and send out the link so that if you didn't get everything, you can get it in a little bit. So what I thought we would do is let's just go through and wherever we're having problems, we can work a problem or two and make sure everybody knows how to work that type of problem, and that way you can ask me questions, and then we'll go from there. Like I said, we have an hour. We actually have 55 minutes left before Zoom will shut us off. Okay, so looking at this list, what is something that you would like for me to work? And if you have a specific problem, that would be even better.
I'm not confused on anything. I just need, like, can you explain significant figures a little bit more?
I
Because
can.
I always mess them up.
Okay, we can do that. So let's look at some sig figs. All right, we'll do that one. All right, what we may do is we'll look at some addition, subtraction, multiplication, division with sig figs, and then we'll work a few problems and make sure the answers are in sig figs. Okay, so that's a good starting point. So I'm going to pull out the packet, and I'm going to go to page 18. Okay. So we know that there are some rules for significant figures, and I'll tell you, sig figs are one of those things that it takes you a few minutes to get them, but when you finally get them, you can't help but do them. They just kind of become second nature. I will have students who will struggle with sig figs for weeks and weeks and weeks. Then finally, towards the end of the semester, they're like, oh, now I finally get it. So if we're looking at this number right here, because there's 3 non-zeros, that tells me that there are 3 significant figures. But we know the problem is when we throw zeros in there. So this 0 is significant because it's sandwiched between 2 non-significant or 2 non-zero digits. This 0 is insignificant. It's important. We have to write it, but it's not considered significant. So this one only has 3 sig figs. Then right here, when we're doing scientific notation, we only look at this part. So that would be 4 sig figs. The number 4 is 4 sig figs. This is, remember I told you that I put this 0 here because it helps me to not lose my decimal. So it is insignificant. So there's only 2 significant figures. So 6 would be 2 significant figures. 7 would be 4 significant figures. And then number 8 would be just 1. These 3 zeros are just placeholders, putting that 9 right there in the thousands place. So there's only 1 significant figure there, okay? So that's how you would find the number of significant figures, but I think most people, they have trouble with doing math with them. So let's look over here on page 19. So when we add or subtract, we look at the number in the problem that has the fewest significant figures after the decimal place. So what I always do is I just go ahead and work out the problem. Let me punch this in my calculator. I get 76.2301. Okay. So if I'm looking at the problem, this one has 4 significant figures after the decimal. This one has 3. So my answer has to have 3 after the decimal, just like this one. So I say 1, 2, 3. So my answer is 76.230. This 0 is significant because it is the final 0 after the decimal place. And that's the rule that usually throws people off. So just looking at these problems, you could go through and say, okay, my answer needs to match that. My answer needs to match that. My answer needs to match that. The one with the fewest places after the decimal. Let's look at number 3. 3 is 93.269 plus 22.2 plus 6.454. And I get 121.923. So 1 place after the decimal, 1 place after the decimal, 121.9. Now, let's just say that you were working one of these problems and it was a whole number. Let's just say that, let's change this one to -8. So now we have 19.7697 minus 8, which gives us 11.7697. Okay. Well, now that this one has no places after the decimal, that means this can have no places after the decimal. So I need to get rid of everything after it. But before I do it, I need to round up that 11 to 12. So this would be my answer. Does that make sense to you? Does anyone have any questions about adding or subtracting?
Wait, why did you make that number just 8?
I just changed it to show you that, let's just say that this was a whole number. There was nothing behind the decimal. And that means my answer can have nothing behind the decimal.
Okay, you just have to round it up.
Yeah. Yeah, 5
Even
or
if it's a
greater, you
number that doesn't round up.
All right. Now, my favorite is multiplication and division because it is so much simpler. You just look at the number of sig figs, period, and your answer has to match it, okay? So on this one, let's do number 2. 0.0021 times 4, and I get 0.0084. This is the smallest number of sig figs, right? Just 1. my answer has to have 1. Now, these are insignificant. That 8 is significant. Does 4 round it up? No. So it's 0.008. Let's do number 4.
So
383.
you don't put a 0 after the 8 because somebody
No.
told me that you have to put a 0 placeholder.
No. If you put a 0 there, that becomes significant because that would be the final 0 after the decimal place.
Okay.
See, the difference between this, that's 1 significant figure, that's 2 significant figures. And we need our answer to be 2. I mean, to be 1, sorry, 1. Okay, let's do 3. 6 times 6.5 gives me 39. This has 1 sig fig. I need this to be 1 significant figure. So I start here. 3 is significant, but 9 rounds it up to 4, but I need to put a 0 there, Lisa. And the reason why I'm putting a 0 there is I need a placeholder. Because if someone owes you $40 and they send you a check for 4, you're not going to be happy. So that 0 is not significant, so it doesn't matter. I can add zeros here. I can't add zeros behind the decimal.
Okay.
Okay. Does anyone have any more questions on 18, 19, or 20?
When you're doing multiplication, you just, like, for the sig figs, you just count how many are in, like, each number. It doesn't matter if it's behind the decimal point.
Right. Adding and subtracting is behind the decimal point. Multiplication, division is just anywhere.
Okay.
So it can be any of them. So like right here, you have 1, 1, 1. So that means my answer has to have 1.
Okay.
Right here, you have 2 and 5. So my answer has to have 2. And I tell you, that's kind of a good rule of thumb. And I mean, these are things that I do, and I have a degree in this. When I'm working a problem, a lot of times I go and I immediately circle the number that's in the problem so that I know how many significant figures I need to have in my answer. Because all the way through college, they'll get you on sig figs. I can remember Miss Russell telling me her son made a 50 one time on a college chemistry test. It was because he forgot to do significant figures, and they took off half on every single problem. So, I mean, this is something you'll use from here on out. So, multiplication, division, fewest
On number 11.
What's that? This one?
On number 11, yes, ma'am, it has the 36 and then it has a 0 after that. Is that 0 significant?
It is. That is a placeholder. That tells us that it's 36 on the dot. So this one has 3 sig figs, and this one has 4 sig figs. The only time the final zeros are not significant are when we're talking about whole numbers. So like right here, this is 1 sig fig. That's 1 sig fig. And that's 1 sig fig. Okay?
Okay, but what if, like, it's a scientific notation, and it, like, becomes a whole number? What happens then?
You just keep counting the sig figs from the number. Now, I will tell you,
Not like whenever it's in scientific notation, but the after.
it becomes a whole number. For scientific notation, this would tell you, this part tells you how many sig figs your answer should have, and you just make sure it matches.
Okay.
Okay. There are, and I can't remember which numbers they are because I don't have them right here in front of me. I know that on this page, there is one that when you work the problem, you cannot get your answer into significant figures unless you put it into scientific notation. One of you may have run into that when you were working it, but I can't remember which one it is. Maybe number 4. Let me
When
see.
we're done with it,
What's that?
I was gonna say when we're done with this, can you get to the conversions quiz on number 13? Because like I don't understand. or like I understand, but I'm still getting them wrong
Okay.
on how to. I don't know.
Yeah, we can do that. On this one, this was a weird one. Okay. So number 4, when you work it out, you get 2100.755. Okay. Well, I need 3 significant figures. So when I say 1, 2, 3, and I come up here and I write 2100, that only gives me 2 significant figures. So to make this one into significant figures, I have to say 2.10 times 10 to the third. Anytime you're working a problem and you cannot get your answer into significant figures, put it in scientific notation.
Okay, I was about to ask, do you mind if we put it in scientific notation, or do you want it to usually always be in a whole number?
I want it to be in standard form unless it has to be in scientific notation.
Okay.
Yeah, that's just, this is the more acceptable format. This is kind of a last ditch that you have to do in the event something doesn't work out, or you're dealing with a huge number or small number.
Okay.
All right.
Are there any more questions like
This? I think there's one over here on this side, but I cannot remember which one it is. That's just kind of a good rule of thumb. If I can't get the significant figures to work out, then I know I have to put it in scientific notation. Okay, so let's go on to the next thing. So that covers sig figs. All right. Anything else on here? How does everybody feel about scientific notation? Everybody good on it?
Yes, ma'am.
Yes,
Okay.
ma'am.
All right. So I guess the next thing would be conversions, because I think conversions were kicking some people's booties. So how do we feel about moving the decimal? Are y'all good on King Henry died?
Yes, ma'am.
Or does anybody need any help with the moving the decimal?
question for number, like the page number 9?
Okay, let me get to it. Page number 9. Yeah.
Okay. So you know that big chart that you gave us that you said you would give us on the test?
Yes.
Micro is right after milli. And
Yes.
so I kind of did the like Henry died drinking chocolate milk thing. But
It
every
won't
time
work.
I do that, the decimal places off.
That's right. It won't work because the King Henry died by drinking chocolate milk. The M for that is milli. But if you look on the chart, you see that micro is 3 more places. See, there's 3 differences. Whereas all these have just been 1 place. That's why we were able to do the little King Henry died by drinking chocolate milk. Right here, you have 3 more decimal places. So you can't move your decimal on that one. That one, you'd have to work it out as a problem. You would have to use a conversion factor, and you would say that there's 1 million micrometers in a meter. Okay. King Henry only works on these right here. And that's because these are all just one decimal place apart. After that, you'll notice they start skipping by 3s. So you can't use King Henry anymore. You have to use math. And this just tells you that there is like 1 septillion meters in a yottameter. There are 1 trillion meters in a terameter. There are 1 trillion picometers in a meter. There are 1 quintillion grams, attograms in a gram. Okay, so you can't use King Henry on that one. All right, so let's look at this page, page 8. Does anyone have any questions or want me to work any of them on page 8? Okay. Page 9, we're gonna skip that because I gave you the answers on it. What about on page 10? How do we feel about cubic conversions?
That's the one on our conversions quiz number 13. That's the one I wanted you to
Okay, well
watch, the cubic
let's
one.
go over how to do a cubic. That's a common one that students have trouble with. So on I'm going to do page 10, number 1. It was 39.09 cubic feet, and they want us to convert to cubic inches. So the first thing that I do is I look for my conversion factor between inches and feet. And I know that there are 12 inches in 1 foot. My difference is we're not dealing with just foot and inches, we're dealing with cubics. So what I've got to do is I've got to cube this. So 12 times 12 times 12 is 1,728 inches cubed in 1 foot cubed. And you may have a cube button on your calculator. Mine is right here over the 1. So to get to it, I have to hit second. So what I do is I'll say 12 second, and then I hit this 1, and that's what I get. Okay, so a lot of times with the cubic, it's just getting your conversion factor. So now I can set it up. I start with my given. I'm going to put in my conversion factor, and I want to put it in so that I get rid of feet. So I'm going to put 1 foot cubed on the bottom, and that puts the inches on top. So now I can cancel out feet, and now I punch it in my calculator. And I get 67547.52, but I'm going to put in significant figures. So how many sig figs is 39.09? Anybody?
Is it 4?
It is. So now I'm going to say 1, 2, 3, 4. Does the 7 round it up? Does. So it's 67550 inches cubed. And that's my answer.
Okay, if that
On the
7
test,
rounds up, why did you make that a 0 instead of a 5?
Right here, because I have to put that as a placeholder. Because I need this to be.
Oh, yeah, I remember.
All right.
on the test, do you want us to put everything in significant figures?
Yes. Every section will have directions and will tell you if you need to put your answer in sig figs. But you're pretty much going to do every problem from here on out in sig figs. All right. So does that help you, Lisa? Do you see what you did?
Question. Yes, ma'am. I don't think it was the cube. I think my issue is going from, like, on that problem, it was going from millimeters to centimeters, and I get really confused on which conversions to use because sometimes I can't find them.
Yeah, you're going to have, and you can put as many conversions as you want to on your conversion card. So, like, if millimeters to centimeters is bothering you, just go put on your card 1 centimeter equals 10 millimeters.
Okay, hold on.
That way you have, you can put as many conversions as you want on that card. Okay,
Is our
Uh,
IONS test still going to be Friday?
it's whatever day what day did I have it listed as? I can't even remember. I don't even know what day
No, I
today is.
don't remember.
I'll have to look and see. I think it was either Friday or Monday. I can't remember. All right.
It
Any
was
more?
the 12th.
What's that?
It was the 12th.
Okay. What is that? Friday? Yeah, it's Friday.
Mhm.
All right. Any questions on any more of these?
Can you do number 5?
Number 5? Yes.
Yes, ma'am. Because it's like the cubic messed me up.
I
So
understand.
5.
I understand. Okay. So they've given us 1,910,000 cubic inches, and they want us to go to cubic yards. So I know that there are 36 inches in 1 yard. So if you don't have that one on your card, you may want to put that one on there. So now what I need to do is I need to get a cubic conversion factor. So I'm going to say 36 times 36 times 36. And when I do that, I get 46,656 inches cubed. And of course, 1 times 1 times 1 is just 1. So 1 yard cubed. That's my new conversion factor. And this is the same thing if you were doing squared. Instead of cubing it, though, you would square your conversion factor. So now I start with my problem. I'm going to put the given down. Then I put in my conversion factor. That cancels out. And now I just put it in my calculator. 1910 000 divided by 46656. And I get 40.9379287. There are 3 sig figs in this, so this needs 3 sig figs. 1, 2, 3. 3 does not round it up, so it is 40.9 yards cubed. That's my answer.
Okay.
All right. Okay, what about rate conversions? Do we need to do any of these?
On page, let me find it. I was just there. I had trouble. Stop biting me. I had trouble doing number 5 on page 23. It's not necessarily rate, but it has, you're changing 2 things.
All right. Okay, yeah. Okay, so let's do that one. Page 23. Number 5. They basically want us to convert density 1.00 gram per centimeter cube, the density of water. They want us to convert it to pound per foot cubed. For that centimeter, yeah, okay. All right, so what we need to do is we need to find a gram to pound conversion factor, and then we need to find a centimeter to foot conversion factor. So let me find my conversions. Okay, so I've got that 1 pound is equal to 453.597 grams. And then centimeter to foot I have, okay, I can do this, 2.54 centimeters in an inch. And then, of course, there are 12 inches in a foot. Okay, so I'm going to have to cube these. Okay. All right, so now I've got all my conversion factors, and I just found all these on that page that I gave you. All right, so I'll start with the given 1.00 grams in a centimeter cubed. And what I'm going to do is I'm going to convert the top first. So I'm going to put my grams on bottom. That puts 1 pound on top. So now I've got pounds. Yay. So now I'm going to convert my centimeters. So I'm going to say there are 16.38 centimeters cubed and 1 inch cubed. So that gets rid of centimeters. And I'm left with inches, but I need foot. So now I'm going to do this one. 1728 inches cubed and 1 foot cubed goes on the bottom. So now I've got foot cubed, so I'm got that, yay. So now I just plug it all in. 1 times 16.38 equals times 1728 equals divided by 453.597 equals, and I get 62.4 pounds per foot cubed. That help?
I did the 2.54 times 12 and got like 30.48, and then I cubed that
That's fine.
and got a big, that works.
What did you get? Was it close?
No.
Okay. Then,
I probably divided or multiplied wrong because there are some really big numbers.
yeah, I don't like big numbers, so I usually do more conversion factors. I tend to lose decimal places, but I will tell y'all there will be nothing like this on the test. There's nothing like this on the test, so don't stress out. If you can work this one, then you're pretty good to go. I'm going to tell you too. I like puzzles, and these types of problems to me have always been like a puzzle. It's all about putting things in the right spot to get rid of the stuff that you don't need and to get what you need at the end. And if you will approach it like a puzzle and that I can manipulate the pieces any way that I need to, you'll do great on these problems. You just got to think of it as this is a puzzle and I can solve it. I just got to figure out how to solve it. All right, so
I
let's go.
also
Yeah.
Cubed the grams instead of the centimeters.
That would be why, because that's going to be a huge number.
Yeah, it was a really big number.
Yeah,
So.
453 cubed is going to be a mighty number there. All right, so
Yep.
that'll kind of throw us off. All right, so anything else on here that we need to go over?
On accuracy and pressure,
Precision.
there's a question. Yeah, thank you. There's a
You-
question on 24, and I just said it was precision, but I wasn't quite sure if it was both.
Let's look at it. Page 24.
Yes.
Which number are we looking at?
Number 1.
Okay. Chemical reaction was carried out 3 times. The mass of the product was 8.93 grams for the first trial, 8.94 grams for the second trial, and 8.92 for the third trial. Under the conditions of the experiment, the results are known to yield 8.60. Okay, yeah, they are precise, but they are not accurate. Accurate means it's correct. They're all very close to one another. They're just not the right number. So what did you say?
I said B.
That's right.
Okay.
Good. Yeah, the accuracy and precision, I always like to do the bullseye. Like this would be me shooting, because I don't shoot bow and arrows. I can shoot a gun. I guess this was a gun. But like if I was shooting arrows, this would be me. Low accuracy, low precision. Okay. Someone whose bow is not sighted in correctly, they may shoot all of their arrows and they may all land in the same spot. That's precise, but it's not accurate, because accurate means it's correct. Then right here, they are hitting the bullseye some, so they've got a good accuracy, but they're not hitting at the same spot every time, so it's low precision. So you want this, like if my bodyguards that I hire for me, they're like this. They have high accuracy and high precision. All right. Any questions on that?
You said number 1
What's up?
on the page. So on number 11, you said it was
You're cutting out, Trinity. Where are you?
number 1 is B.
Yes. Okay, so does anyone else have any questions about this? Okay, so don't forget that on your test, you definitely need your calculator. And then you get to use your conversion card too. And you're going to turn that conversion card in with your test. Your conversion card, you can put any conversions that you want on there. You can put your temperature formulas on there, and you can put the density formula on there, and you can even put manipulated density formula on there. So I think I actually have it all done in this packet. I'm not sure. Like right here, you can put the density, but if you want to put the problem for the formula for finding mass, or how to find just volume, you can put that on the test too, because that'll just save you time. But any of that is welcome on your conversion card. I'm going to give you the big chart, and if for some reason you get in there and the substitute does not hand it to you, it's separate from the test. Like it's in the folder with the test, but it's separate from the test. So make sure you tell her we need this chart too, okay? There are no questions on the test. Everything is a problem-based thing. The only question that you have will be about accuracy versus precision, okay? Any questions about the test? Okay, well, if there are no more questions and I'm gonna shut us down, feel free to text me, and I'll be glad to answer any questions that you may have. I'm steadily grading stuff. I've gone through everything in the Google Classroom, and today I should wrap up your lab reports, and I'm gonna send those back with Jackson so that you can get those back hopefully by Friday, okay? If there's no more questions, then I will talk to y'all later, okay? Bye, everybody.
Bye.
Bye. Hope you do.
Thank you.